Hello guys. Today we are talking about stack organization. Firstly, we talk about what is stack. A stack storage device that store information in such a manner that item stored last is the first item described. We also called last in first out, which is LIFO. LIFO list. Useful for compound arithmetic operation and nested subroutine calls. In stack organization, there is a thing which is we call stack pointer. In short, we say SP, a register that holds the address on the top item is in the stack. The stack pointer is pointing to the top item in the stack. SP always says that SP always points at the top item in the stack. In stack organization, it will perform two operations. First one is push and second one is pop. In push operation to insert an item into the stack, and pop to retrieve an item from the stack. If I talk about in a general language, in stack, if we insert any item, we used to do a push. We push it, we push an item to in it, and if I want to, discard any item from stack, we used to do pop operation for it. A registered stack. If you can see that this is an image of, the block-like diagram. That's how stack is. It is. And at point C, SP is pointing. SP we have also, last slide we have covered it. SP is stack pointer. So it's pointing to the top element of the stack. Okay, so a stack can be organized as a collection of a finite number of registers. So finite number we can say which we can count. So it is stored or we can is a collection of a finite number of registers. Register stack. In a 64-word stack, the stack pointer contains 6 bits. So in a 64-word stack, the stack pointer is correct, contains 6 bits. The 1-bit register full is set to 1 when stack is full. 1-bit register full is set to 1 when it's full. Okay, if a 1-bit full register is set to be 1, so we can say that it's full. An empty register is 1 when the stack is empty. So if empty register is showing the value of 1, so it means the stack is not full, it's empty. The data register DR holds the data to be written into the read from the stack. Okay. So DR is data register which holds the data in it to be written into or read from the stack. So which something written in it and it will push into the stack or it will read something when when stack discard and pop something from it. So it's held by the data register DR, which we can see below to the stack. Stack operation reverse polish notation postfix. Reverse polish notation is a postfix notation. Place operators after operand. For example, A plus B is a infix notation. Reverse polish notation is AB plus, also called postfix. We read this that place operators after operand. So AB is operands and plus is an operator. So in reverse polish notation, AB plus is called postfix of In fixed notation, A plus B. Stack operation reverse, Paul's notation postfix. A stack organization is very effective for evaluating arithmetic expressions. So A into B plus C into D implies A B into plus CD into. So you can see that there's AB into plus CD into AB into CD into plus. So this is the postfix of it. It's like 3 into 4 plus 5 into 6 is 3, 4 into 5, 6 into plus. So first convert the arithmetic expression into the equal to Polish notation. These are the steps we are going through. Push the operands into stack into the order in which they appear. Use the use the two topmost operation for evaluating. The stack is pop and the result often the operation is again pushed into the stack. Finally, only the result of the operation is left on the stack top. So these steps, which we are, according to these steps, the stack operation, these are Polish notation will work in stack organization. Stack operation. So push operation, the process putting a new data element onto stack is known as push operation. Push operation involves a series of steps. So these are the steps. Step 1, check if the stack is full. So if full is 1, so the stack is full. Otherwise it will empty. Step 2, if the stack is full, produce an error and exit. Agar if stack is full, then it will produce an error and exit from it. Step 3, if the stack is not full, increment top to the point next empty space. The stack is not full, so if the stack is not full, increment stop to point next element and at the empty space. Step 4, add data element to the stack location where top is pointing. And on top, who's pointing it? Stack pointer. Do remember it. Then return axis. These are some steps which are using in push operation in stack organization. If you're getting it. Okay, so now pop operation. Accessing the content while removing it from the stack is known as a pop operation. In an array implementation of pop operation, the data element is not actually removed. Instead, top is decremented to a lower position in the actual removed data element and deallocates memory space. Pop operation may involve the following step. Pop operation also have their steps through which it will work. Step 1, check if the stack is empty. Obviously, it will first check the stack is empty or not. Step 2, if the stack is empty, produce an error and exit. If if in a stack when stack is empty, so there is nothing to be discarded from the stack. So it will generate an error and exit from it. If the stack is not empty, X is the data element which is at which top is pointing. So at the top of the top of the stack, the data which we have, which we'll have to discard it in future, so it will pointing to that. Decrease the value of top by 1 and return the axis. So it will decrease the value of top by 1 by discarding it and return the axis. And return success, sorry. So I hope you understand it. So it will, decrease the value of top by 1. So by that, it will discard an element from the stack and the top of it, and it will, return the success. These are the steps through which a pop operation will working out. Thank you so much. I hope